please feel free to remind me. This is my first semester recording, and I sometimes forget to record. All right, so instead of x2, y2, we'll make that xi, yi. Instead of x1, y1, we'll make that xi minus 1, y I minus 1. Okay. And again, the length of your y is going to be delta y, and the length of your x is going to be delta x. Okay. So if we add all of those up together, just all of those little small individual lines, then our length is going to equal the sum from I equal 1 to some big number n of the square root of xi, bless you, minus xi minus 1 squared plus y sub I minus y I minus 1 squared. Oh, sure. Okay. So we know that the length from xi to xi minus 1 is our delta x. Okay, so we'll just make that the sum from I equals 1 to n square root of delta x squared plus delta y squared. Okay, so what if we decide, we're going to multiply this one by delta xi squared over delta xi squared. Okay, so that would give us sum from I equals 1 to n square root of delta x squared plus delta y squared over delta x squared times delta x squared. So all we did was just get the denominator and put it right up underneath there and have our delta x still on the outside. Okay. So if we factor out a delta x squared, okay, we'll be left with 1 here, plus have our delta y squared over delta x squared. And that entire thing would be multiplied by the square root of delta x squared. Oops. Now we know the square and the square root are going to cancel each other out. So that just becomes delta x. Oh, sorry about that. So we have the sum from I equals 1 to n square root of 1 plus delta y squared over delta x squared times delta x. Okay, so we know we want to get our distance between x and y as small as possible because we want to make those straight lines as precise as we can. Okay, so as delta, all your deltas approach 0, your n will approach infinity. Won't reach infinity, of course, but it will just get closer and closer. So as you get those distances smaller and smaller, you get more and more values that you're going to add together. Okay, so that means, add up, that your s is going to equal the limit as all your deltas, your distance between your x and y, approaches 0, the sum of I equals 1 to n, square root of 1 plus delta y squared over delta x squared times your delta x. Okay, so we know that our delta y over delta x, just our dy over dx. Which is f prime of x. Okay, so we'll continue that on the next page. Oh, actually, let me get that. Okay. All right. Oops. Let's make sure I knew where I left off. Okay, so we left off at s equals the limit delta approaches 0, sum from I equals 1 to n delta y squared over delta x squared delta x. Okay. Okay. So we already figured out that delta y is dy, delta x is dx, so that's the limit as your deltas approach 0. So from I equals 1 to n, the square root of 1, plus dy dx squared dx. Which, if you look at it, that's basically your integral formula. Okay, so s equals the integral from sum a to b, square root of 1 plus, instead of dy dx, you can put f prime of x squared with respect to x. Okay, so that is your arc length formula. So you don't have to remember all of that stuff before that. If you have to find the arc length, just use that. So everything before that was just the journey. All right, so if you want to write just a general definition, okay, so let's see if we have y equals f of x, represent a smooth curve. Remember, smooth is just another way to say continuous and differentiable across the entire interval. On the interval AB, or A to B. The arc length of the function. Oh, sure. between A and B is, it's a lowercase s, equals the integral from A to B, square root of 1 plus f prime of x squared dx, or if x equals g of y, the arc length between some numbers c and d is the same formula, that's just f prime of y with respect to y. Or I'll use g prime of y here to avoid confusion. Yep. Thank you. Okay, so let's do a quick example. Okay, so for example, if you want to find the arc length of the graph, say y equals x to the third, or 6, plus 1 over 2x. On the interval 1/2 to 2. Okay, so you don't need the graph, but just to give you something to visualize. Okay, so let's say this is from 1/2, and 2 is about there. So we just want to know the length between those 2 points.
What is the function?
X to the third power over 6 plus 1 over 2x. Okay, so to solve this one, first we're going to need our f prime of x. Then we're going to have to square it and all that other stuff. Okay, so we know the f of x is, I'll just bring that 1/6, make that x to the third, plus 1/2 x to the -1 power. So that means that f prime of x, bring that 3 down, so we end up with 3 over 6. So we'll make that 1/2 x squared. Bring that negative 1 down, so that would be minus 1/2. Minus 1 makes that...
It's a cube.
Hmm?
Nothing.
Oh. X to the negative 2, or just take it right back down to the denominator. Okay, so once we have our f prime of x, we just plug it into our arc length formula. The integral from a to b, square root of 1 plus f prime of x squared dx. Okay, so this will become the integral from 1/2 to 2 and the square root of 1 plus f prime of x squared. So that would be 1/2. Actually, we can factor 1/2 out of both of those if we wanted to. X squared minus 1 over x squared squared dx. Okay. Now to square this, I'll just do that kind of on the side. Okay. So 1/2 x squared minus 1 over x squared times 1/2 x squared minus 1 over x squared gives us 1/4. You have your first, which is x to the 4th. Your outer ends up being negative 1. Your inner ends up being negative 1, so you end up with negative 2 there. Plus your last, which is 1 over x to the 4th. Okay, so you end up with the integral from 1/2 to 2. Let's bring that up some. Square root of 1 plus, we can make that 1/4 x to the 4th. Just kind of combine everything. Minus 2/4. We'll leave it as 2/4. Plus 1 over 4x to the 4th. Or we can make that, yep, x to the negative 4 dx. Okay, so if we combine our like terms there, we end up with 4 over 4 minus 2 over 4, which is 2 over 4. Okay, so that gives us from 1/2 to 2 square root of 1/4. Factor that out. X to the 4th plus 2 plus 1 over x to the 4th with respect to x. Let me clean that up a little bit. Okay, now actually this entire term can be factored to x squared plus 1 over x squared squared. And that square root of 1 over 4 can be factored into just 1/2. So you have 1/2 from 1/2 to 2. The square root of x squared plus 1 over x squared squared with respect to x. Okay, so you have 1/2. Of course, the square and the square root will cancel each other out. So you just have the integral of x squared plus, you can say x to the negative 2, but I'll leave it as 1 over x squared dx. Okay, so if you integrate that, you end up with 1/2. X squared is x to the 3rd over 3. So you have 1/3 x to the 3rd. X to the negative 2, that actually becomes negative 1 over x. And that's from 1/2 to 2. And I'll continue that on the next one instead of trying to squeeze everything here. Wait a few. Did you finish writing that down? All right. Okay, so that would give us 1/2. Oh, let me make sure I know exactly where I stopped off at. Okay, 1/2. So you have 8 over 3 when you plug in your 2 minus 1/2. Uh-oh. Minus, when you plug in your 1/2, you get 1 over, which is 24, 1 over 24, minus 2. Okay, so you end up with 1/2 times, if you want to get all the common denominators, that would be 64 over 24 minus 12 over 24 minus 1 over 24 plus 48 over 24, which would be 99 over 24 times 2, which is 48, which is 33 over 16. Okay, so that would be the length just from 1/2 to 2. Of course, if you increase the length, you increase the length. I mean, increase the length, you get a higher number. All right. Any questions on this one?
I think on the last page,
Mm-hmm.
I got confused. You had a 1 plus 1/4 x to the 4th something.
Let me see.
On the other page.
1 plus 1/4 x to the 4.
I have the rest of that expression in this order, and then moving on to the next step, it had 1/4.
Okay, let me see if I know where. You talking about this step here?
Yeah.
Okay. Oh, that came from this 1/4 here. So you have 1 plus all of this squared. All I did was just square it and
Well, right.
distribute
Step
that out.
after that, I think.
Okay, so the next step?
Yeah.
Oh, okay. All I did was combine the 1, which I made 4 over 4 minus 2 over 4. That gave us the 1/4. So if you have 1/4 here, 1/4 here, 1/4 there, I just factored it
Oh,
out.
okay.
Yeah. Does that make sense?
I believe, yeah.
Okay. So once you did that and you have our 1/4. Yep. So that left us 2 over 4. Factored that out. And this can just factor into that. So. Uh-oh. Got to bring that up. Oh, bless you. So here, just combine those two. All right. Any other questions, or did I confuse you enough for one problem? All right. Okay, so I'll leave that up. All right. Okay, so let's do another example. So let's say if we want to find the arc length. of the graph, let's say y minus 1 to the third power equals x squared on the interval from 0 to 8. Okay. Now with this one, you could solve for y and just use the same formula we used before, but I'm going to solve for x and use the y formula for this one. But it's more than one way to do it. Excuse me. Okay, so if we square root both sides, we have x equals plus or minus the square root of y minus 1 to the third. Or we could just rewrite it as x equals plus or minus y minus 1 to the 3/2. Okay. Now from 0 to 8, this graph actually looks like this. Say if that's 1. Kind of looks like that. Okay, and this point is actually 8,5. Okay. Now the reason that's important is because this interval here is the interval from x. So since we're solving for x and we have now a function of y, we have to find the interval on y. So that's why when we plugged it in from when x equals 0, y is equal to 1. When x is equal to 8, y is equal to 5. So now we have our y value. So instead of the x-axis from 0 to 8, since we're going to use the formula s equals c to d square root 1 plus g prime of y squared dy, we're going to need our interval on the y-axis. Okay, so that means the interval here is from 1 to 5. Okay, so we have our g of y. Which is just our x value here. So here we're only using the plus because from 0 to 8, this graph is positive. So we don't need the minus. So use the positive. Value since the graph is positive from 0 to 8, or x equals 0 to x equals 8. Okay, so we know if g of y is equal to y minus 1 to the 3/2 power, then g prime of y is equal to, bring down your 3 over 2, y minus 1, 3 minus 2 minus 1 is 1/2, and your u prime is just 1, so it stays that way. Okay, so if we plug this into our formula, we end up with our arc length is equal to the integral from 1 to 5 bless you, 1 plus 3 over 2 y minus 1 to the 1/2 squared with respect to y.